Yeah, good evening, boys. Good evening, online students.
Yes. Good evening, ma'am.
Good evening, Danya, Rakshita, and Prajit.
Good evening, ma'am.
Yeah, good evening. I've shared my screen. Visible?
Yes, ma'am.
Yeah.
Yes, ma'am.
All right, children. So today's standard problems from this chapter, heights and distances, or what is called some applications of trigonometry. Okay, the chapter after trigonometry in your NCERT book. Some applications of trigonometry, standard problems from this chapter. Okay, see the first one. The angle of elevation of the top of a tower from a point on the same level as the foot of the tower is alpha. Okay. So without reading further, we'll just start making the diagram. So there's a tower, all right? Angle of elevation of the top of the tower. This is the top of the tower. This is the foot of the tower. This is the ground. The tower is on the ground, right? So this is the foot of the tower. This is the top of the tower. And from some point on the ground, say this point on the ground, the elevation of the top of the tower. So which is the line of sight, the line segment connecting the eye of the observer and the object observed. So the observer from here is looking at the top of the tower. So this is the line of sight. And angle of elevation is the angle between the horizontal. This is the horizontal. This is the horizontal and this is the line of sight. This angle is the angle of elevation, which is alpha. The angle between the horizontal, which is the ground level here. The ground level is the horizontal and the line of sight. This is the eye of the observer and he's looking at the top of the tower. The angle between these two is alpha, the angle of elevation. On advancing p meters towards the foot of the tower. So he's going towards the foot of the tower. He's walking like this. On advancing p meters. So this one is p towards the foot of the tower. The angle of elevation becomes beta. So he moves, the observer, he moves towards the foot of the tower, towards the tower. He walks a distance of p meters. All right, p meters I've marked here. So he takes a new position. This is a new position. He again stops there to look at the top of the tower. So this is again the line of sight. This is the line of sight. This is the observer and he's looking at the top of the tower. So this is the line of sight. And this is the horizontal line of sight. So this is the angle of elevation again, which is beta. The angle of elevation is beta. Show that the height h of the tower. So this is h. The height h of the tower is given by, you can see that expression there. And also find the height of the tower if p is 150, alpha is 30, and beta is 60. So that comes later. So we have to first prove that h is equal to this expression here. All right. Now, mark off all the line segments you have in this figure using variables a, b, c, d, x, y, z, and all that. So we have a line segment here, right? We have this one. Let's just call this x. And look at the expression we need to prove. P tan alpha tan beta over tan beta minus tan alpha, right? So what are the ratios used here? The angles are alpha and beta. The angles in the figure are alpha and beta, and the ratios, the trigonometric ratios applied with these angles are tan, not r, is tan. Only tan is used. Sine, cos, tan, cosecant, secant, cot, only tan is used. So we'll have to consider the right triangles, find tan alpha, tan beta, and get this, show that the height is given by this expression. All right. Okay. So see here. Hi. Gotcha. Now, you can start with any triangle. Take the smaller one, preferably. You can actually start with any triangle. So, in this triangle, what do we have? Tan beta is equal to opposite by adjacent, right? Correct? Tan beta, why tan? Why not sine? Why not cos? Because in the expression here, we have only tan. So we'll find only tan alpha and tan beta. We'll not use any other trigonometric ratio. So tan beta is equal to, I'm taking the small right triangle. How many right triangles are there? Two right triangles. This one and the whole thing. This one we should not take. This one is not a right triangle. We should not take this triangle. It's not a right triangle. Okay. So in this right triangle where we have beta, tan beta is equal to opposite by adjacent, h by x. All right. Now in this equation, tan beta is equal to h by x, which is that term which is not in the final result. Which is that which is not in the final. The final result is h is equal to p tan alpha tan beta by tan beta minus tan alpha. That's the final result. Which is that term or expression which is not in the final result. No, I'm talking about this one. Where is p here? No. Okay, fine. I think I'm not. See, we have this equation from this right triangle, right? Now look at the terms here, tan beta, h and x. Which among these three is not in the final result? That's what okay, I'm sorry. Okay. Which among these three, tan beta, h and x, which among these three is not found in the final result? X. So we are going to write x is equal to h by tan beta. Is this understood? This is fine. Stop there. What can you do with this further? So stop here. This is one. Now take up the other triangle. So what's that? Tan alpha is equal to opposite h by adjacent x plus p. Correct? Now we'll first cross multiply. Or you can even substitute the value of x. See, now what we're going to do in the next step is that we have another equation, right? From the other triangle, we have only two triangles. We've applied the trigonometric ratios in the two triangles. That's it. Now with these two, you have to get the result. With these two, you have to get the result. Now what you're going to do is look at this equation. Here, which is not in the final result, that is, we have tan alpha, h, x, and p. Which among these is not in the final result? X, right? So substitute for x then. So what you do, tan alpha is equal to h by, what is x? H by tan beta. See, instead of substituting here, I'm saying you cross multiply and then substitute. That's what I meant. So that, you don't have a fraction. You don't have a fraction in a fraction. So just for the sake of convenience, I said don't substitute here. Don't substitute here. You cross multiply. So what do you get? Tan alpha into x plus p is equal to h, right? Right? Okay. Now substitute tan alpha into what is x? H by tan beta. So what are we doing? We know we have only two right triangles. We applied tan in both the triangles. So we said preferably start with a smaller triangle. So we started with tan beta. We got an equation. And with that, what did we do? We understood that x is not in the final result. So we wrote x is equal to. Then we took the other triangle. Okay. So you can cross multiply and now ask yourself, x is not there in the final result, right? Here also. X is not in the final. So substitute. You have something for x from the first one. So substitute that here. Because now this is the, this is the only thing you have to get the final result. So now in place of x, use h by tan beta and work this. All right, you will get the expression for h. Now how to work cross multiply, maybe LCM and all that. You should gather the terms that have h on one side. If supposing more than, you have to see the answer, the final result should be h is equal to something, right? So when you work, if supposing you have 4 terms and in the 4 terms, 2 terms have h, you must have the 2 h terms on one side and then take out h common. So you work with the second equation and you cross multiply and all that. You say you have 2 terms in the LHS and 2 terms in the RHS. All right. And so you have 4 terms and of the 4 terms, say 2 terms have h in them, h. You should have the h terms on one side and then take out h common. That's how you can find the expression for h. All right. So see here. Yeah, so you can see here after, cross multiplying and all that, look at all this. So you have 1, 2, 3 terms and this term have h in them. See, exactly what I was telling you in the earlier slide. Same thing here I have. So on cross multiplying and all that, we have 3 terms here. See, 2 terms we have in the LHS and 1 term in the RHS, of which this one has H and this one also has H. So have the H terms on one side. See here, this one has H, this one does not have H, this one has H. So have the H terms on one side. H tan alpha minus H tan beta is equal to, take this to the other side. Then then what I've done is, because this is negative, this one is negative, no? This one is negative. I want to make it positive because you can see the result here. It's positive. P tan alpha tan beta. But I have minus P tan alpha tan beta. So I want to change the signs. So how do you do that on both the sides? Multiply both the sides with a minus sign. If you want to get rid of this minus sign, multiply both the sides with a minus sign. Okay, so what will happen? This one, when you multiply this with a minus sign, so see here, it's like this. Multiply this side with a minus sign and this one with a minus sign. So minus into minus becomes plus here. Here what happens? Minus H tan alpha. You can see it here. Minus H tan alpha. You can see it here. And then minus into minus plus H tan beta. You can see it H tan beta here. You don't have to show that step. Just do that in your mind. I've multiplied. Okay, you can, maybe I'll write it for you. We're just multiplying both the sides with a minus sign. Is equal to minus P into. So that's how we get the next step. And then take out H common and see we got the result. You'll just get it like that without any effort. You'll just get it like that. And then now that we've proved this expression for H, continue to read the next part of the question. If P is 150, alpha 30 and beta 60. So substitute those values here in this expression. Okay, and find the value of H. Please do this. Yeah, do not blindly copy, children. Please understand. And then work out. You are completed, children?
Yes, ma'am.
Okay. So was it easy to understand? Children here? Easy to understand? Or is it challenging? Why no answer to that question? I'm asking online students. Right, Danya, Prajit? Yeah.
Ma'am, it's a little difficult to understand.
Who is that? Florentina?
Yes, ma'am.
You joined late, right? Were you there when I started explaining?
No, ma'am.
Yeah. Okay. Forward, Prajit, Danya, and Rakshita, tell me what's the difficulty?
I understood, ma'am.
I understood, ma'am.
Okay, I'm forcing you to say that you understood. Florentina, I'll come back, okay? I'll proceed, and maybe when I do the second one, you should understand the first one, or I'll maybe let you know at the end. All right? Yeah, children here. Okay. Done, children? Finished, all of you? No? Okay. Okay, so here also Raja also was late to the class. I'd started by the time he came. All right, Florentina and Raja can listen, and others, if you want it again, you can listen. So, with respect to the diagram, Florentina and Raja, with diagram is fine. Florentina?
Yes, ma'am.
Okay, so there's a tower. This is the ground. From here, the elevation of the top of the tower is alpha. The observer moves p meters towards the tower. So this distance is p. He stops here. He looks at the top of the tower. This is the line of sight. This is the horizontal. The elevation is found to be beta. Now we need to find, we need to show that the height h of the tower is given by p tan alpha tan beta divided by tan beta minus tan alpha. This is what we'll have to prove. We'll have to show that the height of the tower is given by this expression. Very simple. Listen to me. Now mark off the other line segments you have in this figure. So let's call this x. And the ratios we see in the final result are tan alpha and tan beta, which means the hypotenuse is not covered there. So that's why we are not marking. See, we don't have to call the hypotenuse here A and this one as B or anything else, because the hypotenuse is not in the picture at all. Hypotenuse comes only when, or we use the hypotenuse only when we use sine, cos, or their reciprocals, right? Yes or no, Florentina?
Yes, ma'am.
Yeah. Now start off with any one of the two right triangles. We'll start with the smaller one, this one. So the ratio you have to use is tan, because you can see in the final result we have only tan alpha and tan beta. So what is tan beta, Florentina? I'm taking the smaller triangle first. You can take any triangle. I always start with a smaller triangle. Yeah, what's tan
Oppositely
beta?
adjacent.
So h by x. Now, what are the terms you have in this equation? You have tan beta, h and x, correct? Now, which of these three you don't find in the final result here? Which among these three you don't see in the final result here?
X, ma'am.
X. So you please write like this. X is equal to h by tan beta. Is this fine? Okay, you have to acknowledge Florentina. Yes or no?
Yes, ma'am.
Yeah. Now tell me what is tan alpha? Quickly. Tan alpha.
H by P.
No? What's tan alpha? H by x plus p, right?
Plus P.
Yeah. Cross multiply, what do you get? Tan alpha into x plus p is equal to h, correct?
Yes, ma'am.
Yeah. Now, in this equation, which is that you don't see in the final result, we have tan alpha, x, p, and h. What is that you don't have in the final result here? X only, right?
Yes, ma'am.
Yeah, now substitute. We have an expression for x. Substitute that here. So tan alpha, open bracket, h by tan beta. Now we are replacing x with h by tan beta. All right, plus p is equal to h. Now look at this equation. All of this is in the final result. Yes or no?
Yes, ma'am.
So in the second equation, again, we have x, which is not in the final result, which is not found in the final result. X is that the term or whatever, which is not found in the final result. So you want to replace that. So you replace x with h by tan beta, which you got from the first one. So x is h by tan beta. Now you can see tan alpha is in the final result, h, tan beta, p, h, all in the final result. Now work this one. How do you work this? So tan alpha, take up the common denominator, tan beta, right? Then h plus p tan beta, correct? Is equal
Yes,
to
ma'am.
h. Yeah. So now you have to, I think after this you can follow. Common denominator, cross multiplying. And then since we are finding an expression for h, you must have all the terms that contain h on one side. So this term has h, this term also has h. So group the h terms on one side. Any side, LHS or RHS, any side, but have the terms that contain h on the same side. And the terms that do not contain h, put it on the other side. Why? Because we have to get the answer as h is equal to an expression. So have the terms that contain h on one side and the terms that do not contain h on the other side. So that's what I've done here. So these two terms have h. So I have it in the LHS and this one does not have h. Put it in the RHS. Now this one is minus. I want to get rid of this minus sign. So I'm multiplying both the sides by a minus sign. I'm multiplying both the sides with a minus sign like this. Like this, I'm multiplying both the sides with a minus sign. So that will give you minus h tan alpha here. And then minus into minus plus h tan beta. And minus into minus plus p tan alpha tan beta. It's like changing the signs on both the sides. Change the signs. Change the signs of every term on both the sides. And that's how you get this one. Then take out h common. H is common. Take it out. And then you get h is equal to p tan alpha tan beta by tan beta minus tan alpha. So we proved this result. Now substitute these values in this result and find the value of h. Is it better now, Florentina?
Yes, ma'am. It's clear, ma'am.
Very good. Yeah. $129 point. Oh. Is equal to 150 by 2 that's the we take A3 as well. As 1.732. As one number can we write as 150 by 2 into what by 3? 1 second, 1 second. I'll just clarify this doubt first. Yeah, 129.9 is what I'm getting. 75 into 1.732. 129.9. Yeah. Now you are talking about which step, Session? This one, huh?
Yes.
Okay.
That I take like root 3 by 2 and write as 150 by 2 into 1 by 2.
Okay, here. So you're saying 150. Okay, let me explain this one. So this one is, this is the numerator, right? This is the numerator, this is the denominator. So what you have, it's 150 by 2 by root 3, correct? That means it is 150. It is actually 150 divided by 2 by root 3. It's like this. See, this is the new, see, this one is the new denominator. This is the numerator. 1 minute, I'll show you. See, this is the numerator. You can see all this is the numerator, right? All this is the numerator. On substituting, we have this. This is the numerator. This is the denominator. Okay, now this numerator becomes 150. And this denominator becomes 3 minus 1 by root 3. Am I correct? Yeah, am I right? Yeah. See, I'll show you again. This is the numerator, this is the denominator. On substituting, this is the numerator and this is the denominator. Root 3 cancel. So this is the numerator now. This is the numerator. And here on taking the LCM, right? You understand? Root 3 is a common denominator. So you will get 3 minus 1. Now this whole thing is the denominator. So it is 150 divided by 2 by root 3. So it will become 150 into root 3 by 2. Correct? This is 150 divided by 2 by root 3 because this is the numerator and this one is the denominator. 150 divided by 2 by root 3. So it will become 150 into root 3 by 2. Yeah, please ask me any questions. Raja? Done, children? Completed this one? All of you finished? Okay, next one. The angles of elevation of the top of a tower from 2 points on the ground. The angles of elevation of the top of a tower from 2 points on the ground at a distance A meters and B meters from the base of the tower and in the same straight line are complementary. Prove that the height of the tower is root of AB meters. All right. Tower. This is the base of the tower. Okay. This is the straight line through the base of the tower. This is the straight line through the base of the tower. Take 2 points on this straight line. Take 2 points. Their distance is, take 2 points on this line, on this straight line through the base of the tower. Okay. The distance of these 2 points, from the base of the tower. See, this is one point, this is the other point. The distance of this point from the base of the tower is A. And the distance of this point from the base of the tower is B. Now, from here, this is the line of sight, elevation, angle of elevation. This is the line of sight, angle of elevation. The angles are complementary. So don't say 45, 45. So if this angle is theta, this one will be 90 minus theta. Because if the angles are complementary, their sum will be 90. So if one angle is theta, then the other one will be 90 minus theta. Or if one angle is alpha, the other one is 90 minus alpha. So now let's read the question again. The angles of elevation of the top of the tower. So this is the top of the tower. You can see the angles of elevation, theta and 90 minus theta. Okay, the angles of elevation of the top of the tower from 2 points on the ground. So these are the 2 points on the ground. On the ground at distance, see the 2 points on the ground at distance A meters and B meters from the base of the tower. The 2 points are at distances A meters and B meters from the base of the tower. See, you should not mark this. This is the distance between the 2 points. That is not given. If you mark this one as B, this is the distance between the 2 points. That is not given. The distance of the 2 points from the base of the tower is given. So, point, base of the tower, that distance is A. Other point, base of the tower, that distance is B. And the angles are complementary. Now you can mark A here and B here. That is fine. You can mark 90 minus theta here and theta here. That's also fine. You will get the same result. Because it's not given that the first point, second point is at this distance. Nothing like that. They've not mentioned that, the distance A units is closer to the base of the tower. Nothing is mentioned, right? So you can take anything. So you can exchange it like this. That's fine. So I'll do it again. See here. This is the tower. All right. This is a straight line through the base of the tower. One point, another point on the straight line. From these 2 points, the elevation of the top of the tower is measured. The elevation of the top of the tower is measured from these 2 points. So these are the lines of sight. These are the lines of sight. The angles of elevation are complementary. So if you take this one as theta, then this one will be 90 minus theta, the angle. All right. Now this is one point. This is the base of the tower. The distance between the point and the base of the tower is A. This is the other point. This is the base of the tower. The distance between the other point and the base of the tower is B. Given this information, you will have to prove that the height of the tower, so you can call it H. The height of the tower, H, is equal to root of AB meters. So when you take this triangle, what will you get? Tan theta is equal to H by A. When you take the other triangle, you will get tan 90 minus theta is equal to H by
A plus.
when you take the bigger triangle, tan 90 minus theta is equal to H by B. That's all. Because from here, this one, from here to here, it's B. H by B. When you take the small triangle, when you take this triangle, tan theta is equal to opposite by adjacent H by A. When you take the bigger triangle, tan 90 minus theta is equal to opposite H by this full thing is B. B, not A plus B. Not A plus B. All right. Yeah, you were right. A plus B minus A. That's right. All right, children. So I think the rest of it you can help yourself. Please do this one. So complementary ratios have been deleted from your syllabus, right? Yeah, so this is trigonometric ratios of complementary angles. Trigonometric ratios of complementary angles. Nothing difficult. So like, you know, reciprocal ratios, right? Sine and cosecant. Excuse me. Sine and cosecant are reciprocal ratios. Cosecant and, cos and secant are reciprocal ratios. Tan and cot are reciprocal ratios, correct? Sine and cosecant, cos and secant, tan and cot are reciprocal ratios. In the same way, we have something called complementary ratios. Complementary ratios. Sine cos, complementary ratios. Sine and cos. Sine theta and cos theta. Sine and cos are complementary ratios. Cosecant and secant, complementary ratios. Tan and cot are both reciprocal ratios as well as complementary ratios. So if you have tan 90 minus theta, you can write it as cot theta. If you have cot 90 minus theta, you can write it as tan theta. All right? Yeah. So tan 90 minus theta, using the concept of complementary ratios, it is cot theta. Now multiply the two equations you have. So multiplying meaning multiply the LHS, multiply the RHS. So tan theta into cot theta is equal to H by A into H by B. So you know that cot theta is 1 by tan theta, right? So tan and tan gets cancelled. So we have 1 is equal to H into H is H square by AB. So on cross multiplying, you get H square is equal to AB or H is equal to square root of AB meters. Done writing, online students?
Yes, ma'am.
Yes, ma'am.
Oh,
Yes, ma'am.
very good. Any questions, children? Please ask me. I can even repeat if you don't understand. Any questions here, children? All right, next one. A vertical tower stands on a horizontal plane. A vertical tower stands on a horizontal plane. Tower plane. Arjun, a vertical tower stands on a horizontal plane, and the vertical tower is surmounted by a vertical flagstaff. So this is the flagstaff. So this is the flag. This is the flagstaff. This is the flagstaff. This is the flag. This is the flagstaff. That stick or rod or whatever it is. So where is the flagstaff? It is on top of the tower. It's on top of the tower. So the tower is from here to here. This is the foot of the tower. This is the foot. It's not in your book. It's only on the board. Okay. This is the foot of the tower. This, this is the top of the tower. This is the flagstaff. This is the flagstaff. I'm not drawing the flag. And okay, let me show it like this. Okay, this is the flagstaff. This is the top of the flagstaff. This is the bottom of the flagstaff, which is also the top of the tower. What is this one? This is the top of the tower and the bottom of the or the foot of the flagstaff. This is the top of the flagstaff. And this is the foot of the tower. All right. So from here to here is the tower. And this one is the flagstaff. All right. Okay. Is surmounted by a vertical flagstaff of height h. This one alone is h. Flagstaff of height h. Not the height of the tower. The height of the flagstaff alone is h. Okay. At a point on the plane, at some point on the plane, the angles of elevation of the bottom and the top of the flagstaff. This is the bottom of the flagstaff. This is the top of the flagstaff. At the same point on the plane, from the same point on the plane. Okay, see, at a point on the plane. At a point on the plane. So let this be that a point on the plane. This is that point on the plane. The angles of elevation of the bottom, this is the bottom of the flagstaff. So this is one line of sight. For the bottom, what is the elevation? Alpha. So this one is alpha. And the top of the flagstaff. So this is the line of sight. This is the top of the flagstaff. Which is the line of sight? The line connecting the point observed and the position of the observer. From somewhere, he's looking at something, right? So you should connect the eye of the observer and the object observed. That's the line of sight. So this is one line of sight. So this is the point on the ground. This is the point on the ground. From here, the observer looks at the bottom. So this is a line of sight. And the elevation is, where do you mark the angle of elevation? Between the line of sight and the horizontal. So this is the angle of elevation, which is alpha. And from the same point, he looks at the top of the tower. This is the line of sight. So which is beta? From here, from this line of sight to the horizontal, this full thing is beta. This full thing is beta. So if you use the bigger triangle, the angle is beta there. In the smaller triangle, the angle is alpha, this one. Alpha and beta respectively. Prove that the height of the tower, you should prove that the height of the tower, this is the height of the flagstaff. Prove that this height, okay, the height of the tower, maybe capital H, or I don't know what I've used, whatever, X I've called it, okay. So prove that the height of the tower is H tan alpha by tan beta minus tan alpha. All right. So the procedure is the same, children. The question may read different, the information is different, but the procedure to arrive at the solution is the same. Okay. Okay. So see here. So you understood the figure? You understood the figure? So now take the smaller of the two triangle where you have this one, no? Alpha. This is the smaller triangle. You can start with any triangle. I normally start with the smaller triangle. Any triangle you can start with. So that's easy for me to deliver it to the children. See, when I'm doing like in one different ways, it becomes difficult for me also to make you understand. So I follow a protocol. So it's easy for me to deliver, plus easy for you to understand also. Yeah. So tan alpha, this one, tan alpha is equal to, yeah, name all the, give variables for all the line segments you will be using in the ratios. Don't write A, B, B, C, C, D. All the line segments, give some variables. You understand me? All right. So now we have not marked the hypotenuse BD and AD because that will not be in the picture at all. We are using only tan. You can see here what ratios to use. Whatever ratios appear in the final result, only that ratio you have to use. For alpha and beta, only tan is used. So use only tan. And when we're using tan, hypotenuse doesn't come. So you don't have to mark the hypotenuse. If the hypotenuse will be in the picture, then yes, you should mark the hypotenuse as whatever P and this one as Q. Now it's not required. So take the small. So you can see this one is given H in the question itself. Don't go ahead of me. Please, we'll go in the same pace. Don't go ahead of me. This one is H is given in the question, right? And this one we have used our own variable X, correct? And this one also we've called it Y. This whole thing we have called it Y. Can you see that? All right. Now take the smaller triangle. Tan alpha is equal to X by Y. X by Y. All right. Now, tan alpha is in the result. Yes. X, you will say it's not there in the result. But X is what you have to find. You should find the height of the tower. And what is the height of the tower? X. That means you want it. Yes or no? What should you find? Prove that the height of the tower. That means what? You should prove that x is equal to. You must prove that x is equal to this. Prove that the height of the tower. What if we call the height of the tower as x? You should prove that x is equal to this expression. So you want x. Yes or no? You want x. So x we want. So x we need because this the height of the tower x is equal to. So we want x. Tan alpha. Yes, we want tan alpha. It's here. We don't want y. Okay, sorry, I used the wrong one. Here. I was here actually. So tan alpha we need, it's here. X we need because it is the height of the tower. Y, no, y is not in the picture in the final result. So we don't want y. That's why I've written y is equal to x by tan alpha. You understand that? Always write this one in terms of what you don't want. So in the final result, we don't have y. So write y, cross multiply. Y is equal to x by tan alpha. Stop there. Take up the next triangle. Take up the next triangle. In the next triangle, we have beta. Again, tan beta is equal to opposite. Be very careful. Tan beta, this is beta. This is the angle beta. It's in this triangle. It's in this triangle. So tan beta is equal to opposite h plus x. And one more thing, children, don't call the whole thing as something. And so the remaining is h minus x. Don't do all that. Mark the line segments independently. Don't call something fully as x and then a part of it is this minus this. Don't do that. If there are 3 line segments and 1 line segment, if there are 3 smaller line segments, mark each of them individually. See, like what I've done here. What I've done here. This one was given h in the question. You don't call the whole thing as x. Don't call the whole thing as x. Then you'll say that this one is h minus x. Sorry, x minus h. If the whole thing is x, then this one alone will be x minus h. So let's not do all that. This one is h given. We'll mark the remaining thing as x. So what do you have? What is tan beta? Tan beta will be h plus x by y. Now use this one in the second equation we've got. Use this one. All right, we know we don't want y. We don't want y, right? So we'll use this here. We'll substitute that here. We don't, where we have y in the second equation, we'll just put this expression. So see here, cross multiply, we get y tan beta. On cross multiplying, y tan beta is equal to h plus x. Now y is that we understood here itself, no, that we don't want y. So what is y? X tan alpha. Put that here. Instead of y, x tan alpha. Substitution. So we're using the substitution method. Now what happens when you substitute? Y is gone. We have replaced y with something else which we want in the final result or which we have in the final result. So y is gone now. You can substitute that y here itself, x by tan alpha. I don't do it there because it might be confusing to cross multiply. So I cross multiply and then substitute. So I cross multiplied. Y tan beta is equal to h plus x. Now y we have here. We know we don't want y. So what is y? X by tan alpha. Put that here. Put that here. Y is x by tan alpha. Then this tan beta is equal to h plus x. Now what are you working for? You're working for x. You must get x is equal to. Yes or no? So you should gather if you have more than one term with x, have all the x terms on one side and the non-x terms on the other side. Why x terms on one side? Because we should prove that the height of the tower. So that is x. All right. So have the x terms on one side and the terms that don't have x on the other side. And so work for x. Okay, do that. The rest of it you should be able to follow this working. Do it, children. So after this, I hope you're all finished. So this is nothing but x tan beta by tan alpha is equal to h plus x. And then I told you, Sashank, since we are working for x, because what is this? Height of the tower, right? That is x. Height of the tower is x. This is the tower. This is the tower. This is the flagstaff. We are talking only about the tower. So that is x. We'll have to show that x is equal to this expression. So this one has x and there is x here. So have the x terms on one side. So x tan beta by tan alpha minus x is equal to h. Okay, so gather the terms that have x on one side, any side, LHS or RHS, any side, but they should be on one side. The ones which don't have x on the other side. So now, whenever then after grouping, should take out, see, not immediately, but you should take out x common. Only then you can get the value for x. Okay, so I've taken the common denominator first because you understand? I've taken the common denominator, so tan alpha. So you get x tan beta minus x tan alpha is equal to h. Then x common. X is common. So you get tan beta minus tan alpha is equal to cross multiply h tan alpha. So x is equal to h tan alpha over tan beta minus tan alpha. And x is nothing but BC. X is nothing but BC. BC is equal to this expression. That's what we had to prove. Correct? Completed, online students?
Yes, ma'am.
All right.
Yes, ma'am.
Very good. Very good. Yeah. So from a window, h meters above the ground. From a window, h meters above the ground. So this is the ground level. This is the ground level. And this is h meters above the ground. And this is the window. This is the position of the window. Whenever we do not know the height of something, we use only a point to represent that. Okay, observer. You know the height of the observer. Then use a line segment. Then use a line segment for the observer. But the same observer, you don't know his height or the height. Nothing is spoken about the height of the observer in the question. Then the observer is represented by a point. All right. So here it's given that there is a window. So window is only a point. The window is h meters above the ground. So this one is not the window. This is that height h meters above the ground. And this is the position of the window. Window is only a dot. This is the ground. This is the ground. This is h meters above the ground. This is the point which is h meters above the ground. And this is the position of the window. And if the observer is watching something from the window, then this will be the horizontal. The line drawn through the eye of the observer, it's on the board. The line drawn through the eye of the observer is the horizontal. Okay, so the window is here. So let's read the question ahead. From a window h meters above the ground of a house in a street. Okay, of a house. There's a window in a house, and that house is in a street. So from a window of a house in a street, the angles of elevation and depression of the top and the foot of another house. So some sneaky peeky neighbor from her window, she's looking at some other, houses, whatever. So the angles of elevation and depression of the top and the foot of another house on the opposite side of the street are theta and phi respectively. Okay, so this is the house on the opposite side of the street. This is the house on the opposite side of the street. Now, how do we know that we have to take a bigger line segment for the opposite house? Because from the window, when the person looks at the top of the house, the angle is angle of elevation. That means the person is looking higher up. From the angle of elevation, depression, you can make out if what the observer is looking at is higher or lower. Where is the observer? At the window here. What is he looking at? He's looking at the top and the foot of a house that's located on the other side of the street. From the window, he is looking at the top and the foot of the opposite house. And what is the angle measured when he looks at the top of the opposite house? Angle of elevation. That means he's looking up. Yes or no? So that means that the opposite house is, that is the top of the house is at a higher level. Yes or no? The top of the opposite house is at a higher level. The top of the opposite house is at a higher level. That is why from here, it is angle of elevation. So connect the eye of the observer and the object observed. The top of the opposite house. The elevation, this is the horizontal, children. The horizontal is drawn through the eye of the observer. The ground level is not the horizontal here. This is the ground level. This is the horizontal because this is the window, and through the window the observer is looking. So from through the eye of the observer, this is the horizontal, and this is the line of sight. From the observer to the point observed is the line of sight, and this angle is theta. Now from the same window, the observer looks at the foot of the house. That obviously is depression. So he's looking down at the foot of the house, right? So from here, he looks at the foot of the opposite house. This is the line of sight, right? This is the line of sight. From here, he looks down at the foot of the opposite house. And how do you mark the angle of depression? This is the horizontal, and this is the line of sight. Between this is the angle of depression, which is phi, phi, phi. This is the figure. Now you need to show that the height of the opposite house is given by h into 1 plus tan theta cot phi meters. All right, the figure is understood. So now you can mark this one. You can mark this as x. Then this also will be x, no? Then if this is h, children, this also will be h, right? Then you mark this alone as something like y or z, whatever. Don't mark the whole thing. This one is h. So the opposite side, this one is also h. The rest of it, you call it as y or z, whatever. And then you mark this one, x. Then the opposite side, this also will be x. Yeah. Now you need to show that the height of the opposite house. The height of the opposite house is from here to here. Correct? Of this height, we already know this is h. See, that h is here in the answer. So you don't have to find this h. You need to only find y. You should find an expression for y. See, this h, this is the height of the opposite house. And the height, this is h, is known to us. That h is, see, x and y we have used. H is already given in the question. And that is in the final result also. X and y we have used. That cannot reflect in the, you cannot bring that in the final result. But h is given in the question, right? H. That is also there in the final result. Yeah, so a part of the height we know, h we know. So you don't have to find this one. You have to find only y. So find y, and y plus h will be the height of the opposite house. Find only y. And once you get y, y plus h will be the height of the opposite house. So this I'll not explain first. I'll allow you to read, understand, and write, and then I'll explain. Is that fine? Yeah. Yeah, sure. Yeah. Now see, if you're distracted sitting together, put Raja in the middle. So figure, children, I had already explained, right? Okay. Yes, see.
So next class is on next Wednesday and Thursday. Okay, thank you.
Yeah, I'm sorry. Yeah. So I was telling you, so again here now, there's nothing like small, big triangle. Start off with anything first. So I've taken BED in this triangle. See, you'll have to use these ratios, children. For phi, you'll have to use cot. You need to find cot phi and tan theta. So here we have theta, Sashank. So here in this triangle, we have theta. So you'll have to find tan theta from this triangle. And in this triangle, we have phi. You'll have to find cot phi. All right. Okay. So in this triangle, cot phi is equal to cot theta is equal to adjacent by opposite. So y by h. Okay. And the same reason, we don't have y in the final result. We have to find x. I told you, you already know this part is h. You need to find this one. We don't want y. See, this is y. We don't want this y in the final result. You can see here, there is no y in the final result. We don't want this one. So we write y is equal to h cot phi and we stop there. Then we take up the other triangle. In this triangle, tan theta is equal to opposite x by adjacent y. And here, I've got x is equal to, I've got something here. From this triangle, I've got something. What did I get? X is equal to y tan theta. I was telling you that we need the value of x. We want x is something, right? So we got x, but in that x, we have y tan theta where we don't want y. So what is y? H cot phi. So I've substituted h cot phi tan theta is equal to x. That means x is equal to h tan theta cot phi. See, before we started, I told you, no, to find the height of the opposite house, we already know this height, a part of the height, we already know h. We just need to find this one, x. Why we know h? Because h is given in the question and h is also there in the final result. So h we know, we have to just find x. And we got x here. What is x? Y tan theta. We got x is y tan theta, but we don't want this y, so we substitute. Y is h cot phi. Y is h cot phi tan theta. X is equal to h. I've just arranged it like I just put tan theta first. So x is equal to h tan theta cot phi. Now the height of the opposite house is x plus h. AB is equal to AD plus BD. AB, the height of the opposite house is AD plus BD. AD plus BD. So BD is h and AD is x. And x is what? H plus h tan theta cot phi. So take out. Okay, who's that? Oh, sorry, ma'am. Okay, yeah. You can come in and sit down. Okay. Yeah. Oh, I'm so sorry. Now, Anike, mask put on I couldn't recognize her. I'm so sorry. Is it time, by the way? It's 9 o'clock. Yeah. Yeah, Chitra. So AB is BD plus AD, that is H plus X. H let it remain. X is what? This one. H tan theta cot phi. Then you'll have to take out H common because that's how it's in the final result here. Take out H common and then 1 plus tan theta cot phi meters. Is that fine, children? Yeah. Which part of it is difficult? Somewhere it's confusing. This one is not easy to understand. Please tell me, because standard questions are the simplest. You get one of this in the exam, easily you can get marks. This is the next one. I'm just coming. Read the question. I'm just coming. Yeah. We took up a numerical problem like this. Okay. The angle of elevation of a cloud, the angle of elevation of a cloud from a point h meters above a lake. Okay, so this is the surface of the water. Okay, this is the surface of the water. And the observer is at a point h meters above the lake. So this is the surface of the lake. And say this is the point h meters. So this is the position of the observer. And where is he? He is h meters above the surface of the lake. This is h meters. Okay, surface of the lake. This is h meters above the surface of the lake. And this is the position of the observer. The angle of elevation of a cloud from a point h meters above the lake is alpha. Where is the cloud? Say like here. What is this? This is the height of the cloud above the surface of the water. That's the height of the cloud above the surface of the water. Now, this is the position of the observer. So the line drawn through the eye of the observer will serve as the horizontal. This is the surface of the water. This will not serve as the horizontal because he's not looking from here. He's looking from here. He's h meters above the lake and he's seeing from here. So this line through the eye of the observer will be the horizontal. The angle of elevation, the angle of elevation of a cloud from a point h meters above a lake. That point is h meters above the lake, not the cloud. I'll read again. The angle of elevation of a cloud. From where are you seeing that? From a point. And where is that point? H meters above the lake. That point is h meters above the lake, not the cloud. Okay. So this is the horizontal. This is the horizontal. And which is the line of sight? This is the line of sight. The line segment connecting the eye of the observer and the point observed is the line of sight. And this is the angle of elevation, which is alpha. And the angle of depression of its reflection in the lake. So this is the surface of the water. So it's reflected below here. It's reflected here. Okay. It's reflected there. Now from the same point, the observer looks down into the water at the reflected cloud. From the same point, he looks and then he looks down. He looks down from the same point. So he looks here. This is the line of sight. The same is the horizontal. When the observer does not change the position, the same will be the horizontal for the angle of elevation and the angle of depression. So from the same point, he's looking down at the reflected cloud. Okay, or the reflection of the cloud. Okay, he looks down there. So this is the line of sight. And this is the horizontal. And the angle of depression is beta. Because this is the line of sight, this is the horizontal. The angle between the horizontal and the line of sight is the angle of depression, which is beta. Correct? Okay. Prove that the height of the cloud is the height of the cloud, meaning above the surface of the water, this height. Prove that this height is given by this expression here. Okay. Now of this height, we know this one is h. We know this one is h. So we'll call only this one as x or something. Okay. And then we might need to use this one. So we'll just call this y. If you have not marked it, when you write the ratio, then you will realize that you need it. Then you can go to the figure and mark it. Not that you should mark it now itself. It's okay if you don't mark. Then when you write the ratio, you will write no tan alpha is equal to then this by this. If you have not marked the variable, go back to the figure and mark it. That's all. Okay. Now, yeah. So this is the surface of the water. What is this distance? From the surface of the water to the cloud, what is the distance? H plus x. So the same will be the distance here, no? From here to here, below the surface of the water. That is, so the surface of the water to the reflection of the cloud also will be h plus x. The surface of the water is a source of reflection. The surface of the water acts like the mirror. Surface of the water, the surface of the lake is the mirror. So from the surface of the water to the cloud, the distance will be equal to the distance from the surface of the water to the reflection. Like the mirror. You stand in front of the mirror. Mirror to you, distance will be equal to mirror to the reflection. Same thing here. So this is the surface of the water. This is the cloud. The height is h plus x. From the surface of the water to the cloud is h plus x. From the surface of the water to the reflection will also be h plus x. Surface of the water is like in the middle. The cloud, its reflection. The distance will be the same. We are ready now. I'll let to use the ratios. Is it fine? Okay. Now see here. I think it's all. Is it clear? Can you all read the figure clearly? I've just drawn it this side, that's all. Nothing to get confused. Don't see the answer. Please look at the figure. This is the surface of the water. So same thing. See h and this is h. The whole thing, this one is x. The whole thing is h plus x. This is also h plus x. This is the cloud. This is the cloud. Now you will be like, why you mark this as z? Don't worry. Don't mark it now. That's all. Don't mark it now. See, elevation is alpha, depression is beta. Correct? Now, we need to use these ratios, children, tan beta and tan alpha. Tan beta and tan alpha we have to use. So take any triangle first. Tan alpha is equal to, I've not mentioned the triangle because I've not mentioned triangle because I think when I do the figure, I forgot to mark ABCD. So I've directly written tan alpha. You understand? Otherwise, I normally mark ABCD. So maybe I forgot. So that's why I've not mentioned the triangle, the name of the triangle. Okay, so tan alpha is equal to opposite adjacent x by y. Correct? Okay, so now to find the height of the cloud, what is that you want to find? You want to find x because this is h, you already know. H is given in the question itself. H is h only. You have to find only x. Okay. Okay, so tan alpha is equal to opposite x by adjacent y. Now we don't want y. Y is that thing which we don't want. So we write y is equal to x by tan alpha. What you don't want, you put it here alone. If you don't want, put it alone. Okay, so y is equal. So we say right in terms of y. So like y is equal to x by tan alpha. We don't want y, so just have it alone on one side. All right. Now in the next triangle, this is the other triangle, children. This is the other triangle. This is one thing. This is the other triangle. Tan beta is equal to, which is tan beta? In this triangle. In this triangle. In this triangle, tan beta is equal to opposite. Please watch out for the opposite side. This is the opposite side, wherein this one is h plus x and this one is h. So the opposite side is h plus x. 2h plus x. Because this is the triangle in which we have beta. This is the triangle in which we have beta, and this is the opposite side, wherein this is h. And from the surface of the water to the reflection is h plus x. So h plus x, opposite, by adjacent is y. So that's what you see here, h plus x, by adjacent is y. So cross multiply, y tan beta is equal to 2h plus x. So now y we don't want, no, so we substitute. What is y? X by tan alpha. So see here, x by tan alpha. After cross multiplying, y is x by tan alpha. So substitute, y is x by tan alpha. So you can see here x by tan alpha. This tan beta is here. Y is replaced with x by tan alpha. And this tan beta is equal to 2h plus x. Now you should understand for what you're working. Now what is your goal? What do you want to do with this equation? You want to find x. You want to find x because you want to find the height of the cloud. Height of the cloud, you know a part of it, h we know. You want to find the rest of it, x. So you're going to you're going to work this equation to find an expression for x. That means gather all the x terms on one side and the non-x terms on the other side. Okay. So I've taken the common denominator. Tan alpha is a common denominator. So you get x tan beta minus x tan alpha is equal to 2h. Gather the x terms on one side, I told you. Then LCM, cross multiply. Cross multiply, I've taken x common. So then you get x is equal to 2h tan alpha by tan beta minus tan alpha. Okay. So we got x. We haven't still got the, we haven't still answered the question. We'll have to prove that the height of the cloud. So what is the height of the cloud? Height of the cloud is h plus x. Correct? Okay. So h is h only, because we want h in the final result. H is the variable which was given to us in the question itself. So you can have it. X and y you should not have, because x and y we wrote. That you should not have in the result. It's not there also, you can see here. Right? So h plus x. So is this part understood, children? So far, is it fine? Online students? Is it okay so far?
Understood, ma'am.
Yes, ma'am.
Yes.
Okay. All right, children. Thank you. So now height of the cloud is h plus x. H plus x. And we found x. X is this one. So h plus, write this one. Now, of course, you'll have to continue, you'll have to take the common denominator. So tan beta minus tan alpha. So common denominator means this one should be multiplied. H into tan beta minus tan alpha. Then plus 2h tan alpha. Open the bracket. Open the bracket. So h tan beta, h tan alpha plus 2h tan alpha by tan beta minus tan alpha. Now, these are like terms kind of. See here, tan alpha, 2h tan alpha minus h tan alpha is h tan alpha plus h tan alpha. Like terms kind of. 2h tan alpha minus h tan alpha. So the answer will be tan alpha. What is 2h minus h? H. 2h minus h is h. Plus 2h minus h is h. So h tan alpha. H tan alpha. Now take out h common. Now take h common. H is common. So tan beta, tan alpha divided by tan beta minus tan alpha meters. That's what it is here. Okay, so next you'll have to show that the distance between the cloud and the observer. Prove that the distance between the cloud and the observer, the point of observation, is given by this expression. Okay, so here you see one other ratio, secant alpha. Tan beta, tan alpha, we've already found here. See, we've already used tan alpha and tan beta. So you don't have to find it again. You'll get the same thing. In the second expression, we have three ratios, which are tan alpha, tan beta, and secant alpha. Tan alpha and tan beta we've already found here, no? So don't work that again. You'll get the same thing. You'll write the same thing. What is new? Secant alpha. Write that. Write that alone. Secant alpha is equal to. So where is alpha here in this triangle? Where is alpha in this triangle? And what is secant alpha? Secant is a reciprocal of cos. So secant alpha will be hypotenuse by adjacent. Secant is a reciprocal of cos. Cos is adjacent by hypotenuse. So this will be hypotenuse by adjacent. So hypotenuse, no, so this is the triangle. This is the triangle. This is hypotenuse. So we marked it Z. So secant alpha is equal to hypotenuse Z by adjacent Y. Z by Y. This Z, children. This Z. Z by Y. All right. Okay. So now what is this? Prove that the distance of the cloud from the point of observation. The distance of the cloud from the point of observation. That is Z, right? So you'll have to prove that Z is equal to. You'll have to prove Z is equal to. So you can have Z in the result. Because Z is equal to, you should get the answer as Z is equal to. So that means you need Z in the result. That Z is nothing but the distance of the cloud from the point of observation. So distance of the cloud from the point of observation is z. So you should get z is equal to this expression. So we have secant alpha is equal to z by y. So cross multiply, you get z is equal to y secant alpha. Y secant alpha. Now we don't want y. So what is y? Go back here. This one, x by tan alpha. X by tan alpha. We don't want x also. Where is x here? Here, x. Replace that also. That's all. I'll tell you again. So use this ratio in the relevant triangle. Wherever you have alpha in that triangle, find secant alpha. You get this. Now, when you cross multiply, you have z is equal to y secant alpha. This is how you want the result. You want z is equal to an expression. This is how you want it. So we have it. But the thing is, we don't want y. We don't want y. We want secant alpha. Let secant alpha be there. This one we want. We don't want y. So come back here. What is y? X by tan alpha. So take away y and write x by tan alpha and secant alpha. That's what I've written using 1. Using 1 means this one. Using this one. 1. Okay. But when you replaced y with this one, we have x. X we don't want. See, we want tan alpha and secant alpha. See here, tan alpha and secant alpha in the result. We don't want x. I don't want x. So again, substitute for x. Where is x here? See here, this one. So using 2. Using 2. X is what? 2h tan alpha by tan beta minus tan alpha. So replace. Instead of this x, write 2h tan alpha. 2h tan alpha. There's already secant alpha. So secant alpha by what is this? Tan beta minus tan alpha. Tan beta minus tan alpha. But there's already tan alpha. So you can see it here. If supposing no, this is difficult to understand, I'll tell you what you can do. I'll tell you what you can do. So this is nothing but this one is nothing but x into secant. This one is nothing but x into secant alpha by tan alpha. That's the meaning. It's like a by b into c. That one x by tan alpha into secant alpha is like a by b into c. So you can write it as a into c by b. Okay. So just separate it. Write that x separately into secant alpha by tan alpha. All right. Now what is x? This one. Write this. X is what? 2h tan alpha divided by tan beta minus tan alpha into secant alpha by tan alpha. So then you can put a bracket, no? Meaning like here you don't have to put bracket here. So this is 2h tan alpha secant alpha, 2h tan alpha secant alpha divided by tan beta minus tan alpha into tan alpha. Am I clear? Yeah. So you can show that step. Just write x separately. So you can show that step. You can write this as x into secant alpha by tan alpha. And then substitute for x using 2. X is this one. So put that. And this is what you will get. So then you see that this tan alpha and tan alpha will get cancelled. So you're left with 2h secant alpha by tan beta minus tan alpha, which is what is the result. And what is z? Z is nothing but the, I'm replacing that z now. Z is nothing but the distance of the cloud from the point of observation. Distance of the cloud from the point of observation. That is what is z. So therefore, distance of the cloud from the point of observation is 2h secant alpha by tan beta minus tan alpha. All right. Yeah, work this to do. Take some time. No hurry. All right, children, it's time. So, shall I share this image on WhatsApp so that you can go home and complete it for the next class? I'll do that, yeah. Online, children. Since it's time, I'll share the image on WhatsApp. You have the advantage of taking a screenshot also now. Yeah. So share the image on WhatsApp. All right. So please complete this by the next class. Yeah. All right, children. So that's it for today's session. Thank you so much. Online students can leave the call. Thank you, children.
Thank you.
Thank you, ma'am.
Thank you.
children. Thank you. See you.